Right, okay, I'll do a fuller presentation on cadmium toxicity fairly soon. This is just an introduction in the context of the lab. Yeah, bear with me a second. Okay, cadmium toxicity is associated with a range of negative health outcomes. As I mentioned, I'll do a longer presentation on this fairly soon. Note from the table that although crustaceans like crabs may contain quite high amounts of heavy metals such as cadmium, they form a relatively small amount of a typical person's diet. See the FSA link here if you want more information. There's a link there. Oops, going the wrong direction. Other environmental source of cadmium. It's noticeable that smokers are at increased risk. This is due to more efficient intake when inhaled compared to absorption via the gut. Again, as usual, my images all have links to various information, including a Food Standards Agency report from a few years ago. Best way to analyse metals in food is ICPMS, ion-coupled plasma mass spectroscopy, and we have such an instrument. These are quite an expensive piece of kit. Not many universities allow undergraduate students to use them. We'll have a more detailed look at the method later in the module. This is just a sort of introduction. And to have a good introduction, just have a quick look at this video. It gives a good overview. I'm not going to play it here, but you can have a look at it in your own time. We discussed the need to extract analytes before we can analyse them in the lectures. This is true of the vast majority of things we want to analyse in food. In this case, the extraction is done in nitric acid solution with microwave heating to accelerate the process. The ICPMS records the data and calculates the concentrations of many metals, including cadmium. As I mentioned in a lecture, it's a rare example of a technique that is both qualitative, it tells us what metals there, and also quantitative. It actually tells us how much of each metal is present. This equipment used. The technicians will walk you through the process. The digestion converts organic compounds into inorganic compounds. For example, the carbon and hydrogen backbones of molecules will be converted into carbon dioxide and water. Nitrogen or sulfur from amine groups or disulfide links in proteins will be converted into nitrogen oxides and sulfur dioxide respectively. These are gases, of course, and the digestion tube needs to be cooled and opened carefully. ICPMS detects down to very low levels indeed. It's a terrific technique. And as I say, quite expensive in terms of buying the kit and also running the equipment. If you really want to know more about ICPMS detection limits, you can link through this paper. We can easily detect cadmium down to 1 nanomole. This is a very small amount, as we can see from the figures there. 10 to the minus 9 moles, so a billionth of a mole, I beg your pardon, 1,000 millionth of a mole, or a billionth of a mole, depending on which way you look at this sort of thing. Okay, some results from a previous student project. This was a project done by an MSc student in cadmium in locally bought crabs. In some cases, the amount was found over the EU limit. Other projects we've done, we found it was below the EU limit. It probably depends on a range of factors, some of which we've discussed. Time of year, where exactly the crab came from, how old the crab was. All the ones are liable to concentrate in more, you would think. So to do this properly, we need to do a really big survey. And when we do projects, we're just looking at students developing their understanding of techniques. Since ICPMS simultaneously analyses a wide range of metals, an estimation of mercury was also done. Again, in some cases, the amounts were found to be above the EU limits, as we can see here. Contamination by mercury has caused some very serious issues. See the links here, particularly the one on Minamata disease. Yeah, so closing the loop. This is obviously based on the food science and chemistry module, but it does have links directly through to health and nutrition, and this is a good example of how this works. Oily fish is a good thing. As this NHS resource states, a healthy balanced diet should include at least 2 portions of fish a week, including one of oily fish. Most of us aren't eating this much. A portion is around 140 grams. Now, some sources of oily fish, such as salmon, are relatively expensive. However, sources such as tinned sardines are much cheaper, although they have gone up a lot in the past few months. A typical tin there has gone from about 90 pence to about £1.30 in the past few weeks, because of a range of factors. So that advice is okay for most people. However, the NHS recommends lower amounts for certain groups, including girls and women who are pregnant. This is because oily fish tend to have relatively high amounts of toxic metals, particularly mercury. A major source of pollution is from coal-fired power stations. Mercury in the form of methyl mercury is absorbed by krill and is then bioaccumulated up the food chain all the way up to us. We understand these serious issues in large part because of analytical chemistry. So a link there between analytical chemistry and nutrition. Okay, that's all folks. Thanks for listening.